Now, if that's true, we still haven't answered the question, how big should a sample be? So, let's continue. What I want to know is, if I have a particular margin of error in mind that I'd like to have, how do I know ahead of time how big a sample I should collect so that when I run through the formula, I get this? Well, that's easy enough to do. All we have to do is do a little algebra hocus pocus and rearrange this formula. So instead of telling me how to calculate E, rearrange it so that N is by itself, so it tells me how to find N. That is, it'll tell me what the minimum size my sample should be. So let's do that. Let's do the math. Here's the formula again. E equals E sub alpha over 2 times the square root of p hat times q hat divided by n. Okay? I want to solve this formula for n. So the first thing I'm going to do, those of you who are algebra scholars should know that the first thing I should probably do here is square both sides. Get rid of the square root sign. So I'm going to square this side, and I'm going to square this side. Okay, well that's easy. On the left side, that's just e squared. Over here, to square everything means to square every factor. So I'm going to square this z sub alpha over 2. And when I square a square root, hopefully you remember that they just undo each other. And that just results in p hat times q hat without any square root sign over n. Okay? Now, next, we're looking for the worst case. What is the really the biggest this minimum sample size has to be? So worst case would be when p hat and q hat give me the biggest number. We already looked at that earlier, right? The biggest product for p hat and q hat is when they're both 0.5, and so the product is 0.25. So let's take the worst case scenario, and let's just replace this p hat and q hat with 0.25. And there's another reason for doing that besides what I just mentioned here. If we're just getting ready to go out and collect a sample and try to decide how big it is, are we going to know what p hat and q hat are? Well, no, we're not going to know them until we actually survey the sample. So I'm not going to know this information ahead of time. So very often we assume the worst case and assume this is just 0.25. And this is still over n. Okay, a little more hocus pocus now. I know that anytime I have a whole number equal to something that has a fraction in it, that I can switch the whole number with the denominator of the fraction, and my resulting equation will still be true. Now you may be saying, what the heck did he just say? Okay, let me do a simple problem. How about we take something simple like this? How about we come over here and say 3 equals 6 divided by 2? You all agree with that, yes? I'm claiming I can switch the whole number with the denominator, namely put the 2 here and the 3 here, and I still get a true statement. I claim I can do this with all numbers, well, except for 0. So even though I don't know what these are, I can switch them. I'm going to switch my n, the denominator, with the whole number over here on the other side. So I can say n equals z sub alpha over 2 being squared times 0.25 over e squared. Okay, it looks still pretty like an ugly formula, but I notice that this is a square and this is a square. Well, gee, 0.25 actually is a square. 0.25, where did that come from? That came from multiplying 0.5 times 0.5. So really, this 0.25 can be written just as 0.5 squared. So if everything here is a square, my critical value, my 0.5, and my e, well, I can really simplify this quite a bit by writing this all together. And I'm going to put the 0.5 first and make it part of the numerator with my z sub alpha over 2, z sub alpha over 2, and e, and realize that all of this is supposed to be squared. So I'll just put parentheses around the whole thing. And here we have And by the way, this formula is going to look a little bit different than what's in your textbook, a little bit different than which is on your formula sheets. And if you feel comfortable using that formula, use that. But I kind of like mine. I think it's a little simpler. Here's what it says to do. Take your z sub alpha over 2 value, which is going to be one of these four, based upon what confidence level you've picked. Pick your z sub alpha 2 value. Take half of it. That's what 0.5 means. Take half of it. Divide that by the margin of error that you want, E, and then square that. And when you do, you'll get a value for n, which will be the minimum size for your sample. If it doesn't come out to be a whole number, then just round it up. Always round it up. Always take the worst case scenario. So we have to actually survey one more person than we think we may have. You know, it doesn't hurt to survey more than you need. We don't want to survey fewer than we think. We always want to survey more than we think we have to. Please keep in mind that margin of error is normally expressed as a percent. Since p hat is a percent, and we're going to p hat plus e, this is also a percent. But when we're doing math, this e is actually a decimal. For example, if we're talking about we want a margin of error of plus or minus 2%, then we would first write this as 0.02, and that's what we would put in there. So as you can see, we're dividing by a, like 0.02 is a pretty small number. When we divide by a small number, that gives this a big number, then we're going to square it. So, as you might guess, we have to have a pretty big number of elements in our sample when we're dealing with a proportion. So, I think it's time to actually do an example. So in my next video, let's take all this what we've done, and let's do a specific example.